All right, so today we're going to be talking about cross-site request forgery, which is a security-specific or security-related topic. Oh, and it's sometimes called, by the way, it goes by a lot of names. So you'll see CSRF, XSRF. Sometimes people pronounce it CSRF, session writing. There's a few others, so just be aware. But this is the kind of the official name for it. So why should we learn this or be aware of it? OWASP is a international organization which basically tries to provide security guidelines for developers around the world. And every few years they publish basically like a top 10 security concerns. The 2017 one was actually supposed to be approved, I think, 1 month ago or so. And I think this is actually a draft, but it should be approved very soon. They had one in 2013 that was pretty similar. A couple things shuffled around, but for the most part, you'll see that we have some pretty common security exploits or potential vectors that attackers can use against developers that have been with us for some time now. So there's 3 that are pretty well known, which are SQL injection or injection generally, which is actually number 1 on here, cross-site scripting or XSS, which is number 3, and then cross-site request forgery does come in at 8 here. So it's definitely another important one. But also, it doesn't seem to be very well known or at least well understood by developers. So most developers have maybe heard of it, but they tend to be a little more familiar with the inner workings of cross-site scripting and injection, but not as much about cross-site request forgery. There seems to be a lot of confusion about it. And then lastly, it has affected a lot of companies and applications. It's actually also an interesting attack in the sense that it's very likely that it's highly, highly underreported because as we'll see when we get a little further in the discussion, the attack looks very authentic, and it really does look like it originates from the user. So it has the user's IP address, as well as a lot of other information like their cookie. And so it's pretty nuanced sometimes to distinguish between a legitimate request and a false one or a forged one, which is actually why this is a security exploit to begin with. But you can see on there it's affected Netflix, YouTube, MuTorrent, ING Direct. This is just to name a few. Even Google also has been a slightly different kind of specific version called login CSRF. We probably don't have time to cover that today. But certainly there have been many people impacted by it. So quick example, what exactly would this look like? This is a very basic and simple example. There's actually 2 quick versions here. So the first one is a GET request. So we're going to send basically a GET request to some bank's website. And you can see there's some query strings or parameters on the end of that URL there. And basically, we are trying to fraudulently move some money from one person's account to another person's account. And if this website was vulnerable to CSRF, all that you would need to do is manage a site that you could get someone to visit, some type of malicious website that has this A tag or link on it. That tag, if the person were to click that link, would then send that GET request to the bank. And because it's the user who's actually doing the clicking, it's actually coming from their computer, and their cookie is also stored on their computer. So the website actually gets confused and think this is legitimately coming from the user, and then you're out $10,000 or however many dollars. So pretty dangerous. And then the second version is, in addition to an A tag, by the way, you could use an image tag. So either one of those would work. For post, it gets slightly more complicated, but it's definitely still possible to do. Instead of an image or an A tag, you'd have to use something like a form. But you could, of course, hide the form and put the action as the target URL. And then, again, embed some of those parameters in the input. And then also, the user actually wouldn't even have to hit the submit on your kind of fake form on your website, because you could, on the loading of the website, you may be able to run a script which submits the form as soon as the person comes to your website. So pretty scary stuff. Quick definition from OWASP. Again, basically, it's an attack that it makes an end user execute some type of action that they didn't mean to do, and it wasn't supposed to be authenticated by them, but because of some trickery that's going on, and maybe a help of little social engineering, like sending someone a message with like a link that goes to some malicious website, that's typically how something like this can happen. So some more specific details. The type of the attack is called a confused deputy. All that means is that's kind of a broad class of attacks where a confused deputy, which in this case would be the browser, mistakes someone for basically someone else or something else and grants them privileges that they shouldn't have. So it's actually kind of a specific type of privilege escalation. And the way this bug works, or the reason it exists, I should say, is that it basically hijacks the inherent browser functionality of automatically sending cookies to any domain that you currently have an active cookie for, and also some aspects of HTTP specification regarding cross-origin requests. So here's a really quick diagram that I got from a great blog post. I can provide that at the end as well. But basically, this is how it would look. You go to an attacker's website, and they serve you up some type of HTML. And then in that HTML, in the background, it's hidden from the user, but it actually sends a request. Has your computer send a request to some other site they think you might happen to be logged in at right now. They'll just guess. So maybe a bank or a Facebook or whatever, some website. And your browser will just say, oh, OK, we're sending a request to this domain, so send along our cookie as well. And then this is how you kind of get this attack to work. It should be pointed out, and I think this is kind of a point of confusion, that the attacker doesn't see the response data. So it's only used for state changing requests and not reading of your information. So they might like update your mailing address, or they may be able to like update your password, or do all kinds of things, but they can't just read the information typically that's coming back. But that being said, and I'll touch on this again at the end, that's actually not true if your site has any single vulnerability at that domain of an XSS type. So yeah, again, you have to be very careful to watch out for multiple security flaws, not just CSRF. So how did we get here? Of course, we want users to be able to log in. And to do that, they provide a username and password typically. They can also provide a token in some instances. But let's say username and password. We, of course, don't want the user to have to supply that on every page. We need to kind of remember for some amount of time, let's say 10, 15 minutes, however long they're using our site, that they're currently authenticated and logged in as the person who we just saw visit our site. Because HTTP works in a very stateless way, so the client and server don't have a consistent knowledge of what's going on. It's kind of just like a pinging of messages back and forth. So obviously, many websites want to use this type of login functionality. So cookies were kind of invented, or one of the reasons they're commonly used is for this functionality, is to basically put like session information on a cookie. Another reason is relaxed origin policies. So there is a somewhat newer specification called CORS, or cross-origin resource sharing, I believe it is. But basically, that helps govern XML HTTP requests, which are cross-origin in nature, because traditionally those were governed by same origin, meaning you weren't allowed to use an AJAX or fetch request to another origin if it wasn't your own. So persistent authentication was the problem I was just referring to. How do we go about solving that problem, right? So basically, you have one of two options. The first of which is kind of the classic or more traditional approach, maybe, which is you store some kind of, and of course, by the way, a lot of these values are encrypted and hashed and so on, so I'm not even covering that. We don't have time to discuss all of that. But the session ID that you create for this user can be stored on the server. And so when a user comes to your website, they send you their username and password. You send them this session ID back, and you tell their browser to set that in a cookie. So now your browser has this cookie information with your session ID, and now every time your browser goes to that site, if it has a cookie for it, it will send a cookie along with all of its following or subsequent requests. This is definitely one approach you can use. You'll typically want to use a flag on the cookie called HTTP only. That prevents the front-side code from reading or writing to that cookie header information. So it's not able to access or kind of play with that session ID information. And so it's not vulnerable to cross-site scripting attacks. But it would still be vulnerable to cross-site request forgery, which is what we're discussing today. The other option you have is to store session information on the client side. That has some pros and cons to it as well. That is actually no longer subject or susceptible to cross-site request forgery. So I should clarify that CSRF is specific to cookies. So if you're not using cookies to create a session and authenticate your user, then actually you don't need, as far as I'm aware, to be concerned as much with CSRF. But the downside is you are still vulnerable now to XSS, which means if you have any cross-site scripting vulnerabilities, an attacker may be able to see a user's session information in the browser. So really quick, some inadequate mitigation strategies that people have thought up in the past. First one is refer headers. So sometimes people will think, oh, well, this request is coming from the user's computer, but we can still see that it's this malicious website that's reaching out to us for this, for requesting some source, an image or a script or whatever it happens to be. So let's check where this is being referred from. The problem with that is there's actually not a very consistent implementation of refers. A lot of browsers or proxies will strip away refer information for privacy reasons. So it's not something you can consistently rely upon that it will be there. You're going to get a lot of false positives, in other words, if you try to enforce that. Another one is HTTP verbs. As we saw, even though if your site allows GET requests that are not idempotent, that's obviously very bad design. It makes you a little more vulnerable to this. But even if you make sure all your requests that are idempotent are posts, you are still vulnerable to CSRF because, again, someone could use a form instead of an image resource to kind of attack the website. And lastly, URL rewriting would be putting the session ID in the URL. That technically may be safe in certain situations, but it's generally frowned upon because, of course, if that URL gets exposed in any way, kind of in transit somehow or in some other manner, their information would be compromised. So what are actual legitimate mitigation strategies for CSRF? One is reauthentication. So that one is basically just prove to me again that you're actually who you say you are. One of the early things I said was it would be annoying to a user to have to submit username and password at every single screen. That's true. But if they're doing something that's pretty dangerous or has a really big impact, like I'm trying to transfer money out of my account or I'm trying to delete my account or something high level like that, it wouldn't be as big of a nuisance on those types of requests to say, you know what, go ahead and enter your username and password again now. Or as long as it's, and we again don't have time to go into the details of this, but if it's securely done, you can do something like a CAPTCHA, which is also a little bit harder for an attacker to request since they're not using that user's browser. But probably the go-to method is actually to make unique form tokens. So any form or link you have on your site, you should have also these uniquely generated tokens that actually need to be sent. It's maybe a little annoying to keep track of everything and implement, but they need to be sent on every post, put, or delete request. And then you include that token in both the cookie header and the body of the message so that even if an attacker can act as an impostor and has your cookie in the headers, they will not be able to access the code that was running in the browser at the time, so, again, unless you have an XSS vulnerability. But assuming that's not the case, they will not be able to read that secret token that was a value on some form, let's say. So they won't be able to impersonate you anymore, and then you'll be able to get around CSRF. Lastly, I would say is know your libraries. So of course, you know, we're going to use all kinds of libraries and frameworks as well to set websites up. So there, and many of them need to work with Node, Express, and Sessions, and so on, Passport. There's many of them out there. But just definitely read the documentation and be aware of what the library is handling for you and what it's not. Because if it's not handling CSRF for you and you're not thinking about it, then there's a very good chance that you could be vulnerable. OK. Are there any questions? Awesome. Thanks so much for listening, guys.